Welcome to our next webinar. We're just doing a sound check right now, and we'll start shortly after the sound check. Michael, can you just do a quick check?
Sure. This is Michael Bean. I hope everyone can hear me.
Great, that came through.
This is Bob Eberlein doing a sound check.
Great, that came through loud and clear. We will be starting in approximately 1 minute.
Good afternoon, and welcome to our series of webinars on XMILE, system dynamics, and big data. We've seen a number of really great use cases for system dynamics in this series, and today we have the privilege of welcoming Michael Bean, who's going to go through a number of different applications that they've done. One of the powers of XMILE, as we see it, is bringing system dynamics to a much, much broader audience. And one of Michael's goals in the work that he's done is to make available to a wide variety of people the kind of simulation models that we do in system dynamics. And so he's going to talk not only about how you get those to people and how you engage people in using those kind of models, he's also going to show us a number of examples of models where they have been used. I've known Michael for a long time, and it's my pleasure to welcome him to the series here, and really look forward to hearing his presentation. Michael?
All right, thanks, Bob. Okay. So I'm going to be talking about predictive analytics sims today. And many of you probably have heard simulations described as a management practice field, or sometimes the analogy of a flight simulator for managers is used. And the concept behind this is that managers can build their cognitive muscle and are able to respond quickly to changing situations. But here's the management practice field idea, right? So there's a problem with this analogy, which is that for pilots and athletes, practice is about improving their ability to make quick decisions. And they might run through the same kind of practice for hundreds of hours. But making quick decisions based on intuition isn't something that most managers need to do. There are some special circumstances where people need to be able to respond in the moment. For example, a call center is an example of that, where people are interacting with customers and they need to be able to figure out how to respond instantaneously. Another example might be, negotiations, for example, on the trading floor of an options exchange. But for the most part, those are special examples. And in those places, it does make sense to practice hundreds of hours the way the athletes and pilots do. But most management decisions, they take place over days or weeks or sometimes even months. And you don't need to make the practice the same thing hundreds of times, but instead what you're really doing is you're trying to convince either yourself or other people what it is that you need to do. So the kind of online analytics tools I want to show today that are based on system dynamics models, they're really not framed, or I'm not framing them today as management flight simulators, and I think of them they're best described as leadership support tools. So, if effective leadership is hard to characterize, right? So, there's lots of descriptions of it. There's lots of ways that people frame what leadership is. But I think the best description, or a good description anyway, of what leadership is that leaders anticipate events, they prepare for them, and then they influence organizations to act in time to shape them. So, that's the goal of what leaders do, and these analytical tools are supporting leadership by doing a few things. I'm going to leave out the middle one for today and just focus on this influence organizations and anticipated events. And I'm going to show you 4 simulations today that sort of illustrate how those concepts work and how they can support management decisions and leaderships within organizations. So I'm going to start with the ones at the top here, the influence organizations. And the first one here is this Latino Vote Map. And I want to frame this a little bit, too, in terms of what it is the tool is trying to accomplish and how it deepens the understanding of groups, how it's helping with influencing organizations. And in this case, a big part of this is that during the 2012 U.S. election for president, and then also actually this year there's a gubernatorial and senatorial election coming up in November of this year, and then of course there's the 2016 presidential election coming up. There's been a lot of news about the fact that the U.S. electorate, the Latino portion of the U.S. electorate is growing, and they're having a bigger impact on national elections, and that's kind of an established fact. People can sort of understand that, and without really digging into details of what the details mean about it. So let's take a look at some examples of that. And what I want to do is actually start off with something that appeared in the Wall Street Journal, because I think this frames some of the difference between tools that are model-based, that have predictive analytics tools behind them, and tools that are more about just a static database. So often when people are talking about interactive tools online, what they mean are visualizations that rely on a static database. So it is interactive in a sense, but it's not as interactive as sort of anticipating what might be happening in the future and being able to anticipate what the future might look like. So here's an example of that. This is a Wall Street Journal piece on that demographics are changing. It's specifically about the fact that the Hispanic or Latino population in the U.S. is growing fast. And here we can see the white population for various states. And for some reason in this piece, what they've done is they've framed it in terms of the change. So strangely, I think, for example, California, well, let's go to Hispanics. So California is lightly colored here. And the states that have the biggest change are states that have a starting point with relatively low Latino population. So, but the states with the largest Latino populations tend to occur in the Southwest here, like California and Texas, for example. And what you can see here is you can kind of maneuver through this, and you can look at various populations. But all I'm really doing here is just accessing the same data, and it's appearing, and I'm sort of slicing the database in different ways. So this group, or these groups actually, Latino Decisions in America's Voice, we're interested in explaining in more detail about what would happen if the Latino portion of the U.S. electorate had a bigger influence on the 2012 presidential election. And we helped them with that by building out this tool that sort of allowed people to experiment with assumptions around how around what would happen during the election. So, for example, how many Latinos are likely to vote relative to the U.S. electorate, and how many of them are likely to vote for Republicans versus Democrats during the election. And what you can see here is you do have this ability to kind of drill down into detail. So if I look at, let's say, Texas here, I can see that, I can see something about the number of voters and the fact that the growth in the eligible voters has changed significantly over the last 10 years, and that there's a lot of them within the state there. But what I can't do is get an understanding of, like, how is that going to actually influence the outcome of the election, or if it will at all. And also, what kinds of things might occur that might influence the results. If, for example, there's more canvassing that goes on, or there's increased awareness of Latino issues that gets more Latinos to come to the polls. So here, what I can do is start to experiment with that and say, I'm going to change the assumptions that I have about what's going to be happening during the election, about the number that participate. And you can see that's changing the results for the turnout. And then I can also experiment with things like, what if more vote for Republicans? What if fewer vote for Republicans? What's the outcome there? And so I can see that, Texas, which actually turned out to be a red state in this case. If more Latinos had turned out for the election and fewer of them voted for Republicans, then it could have switched over to a lightly blue state, could have swung slightly in favor of Obama. And we can look at those alternatives too, where in other scenarios where especially if we allocate the virtual ties where Romney wins the election. So there's a wide variety of outcomes. We're looking at this historically now, but for the senatorial election and the gubernatorial election, as well as the 2016 presidential election, this will be something where people want to experiment with it. And related to this actually is live data that's feeding into it that's helping people understand what's happening and getting the latest results into it. So during the 2012 election cycle, there's polling that's going on, and those polls are coming out sometimes daily, but mostly weekly throughout the election cycle. And the polling data, as it gets updated, needs to be updated within this interface. So there's sort of a connection to live data here, where the new polling data gets uploaded and provided, and that's influencing both the initial settings for this as well as sort of the setup in terms of how the election might turn out. And you can see here that it was last updated at December 12th or December 10th, 2012, about a month after the election was over. So that's just sort of an example one example of influencing organizations using it. I want to move on to another tool that's around influencing organizations, and this is around this cost of capital tool. And the idea is that there's a couple of authors who wrote for Harvard Business Review that wrote an article about how assumptions about the cost of equity and debt can affect both the type and value of investments that a company makes. So that's the broad concept. And they wrote this article around, do you know your cost of capital? And it's a typical Harvard Business Review article that talks about various assumptions that go into determining what your cost of capital is. So it looks at what your forecasting horizon is, that can influence it, what your cost of debt is, and kind of what other organizations are doing with that. And so there's some good information there about various ways that a company's cost of capital could be affected. But it's difficult to do an analysis of one's own organization with this, and also to see where leverage points might exist. So we helped them by building out this cost of capital tool. And you saw there, hopefully, when I was just loading that it took a minute to load. And the reason for that is that the way this particular tool works is that it loads today's rates, today's reference rates here, which could be the current 30-day or 3-month LIBOR, or 10-year Treasury, and so forth. So those are the today's rates that are kind of loaded in the system. Those come from an API from the St. Louis Federal Reserve that kind of feed into this thing. And what you can do with it is experiment with different values and see, for a hypothetical project in this case, whether or not it passes net present value, whether or not it's sufficient to accept the project, essentially. And if I go in here and I say the 12-month LIBOR, and I switch back, so now I can get it with a certain settings here. I can get it so that my NPV is positive, but with other settings for this particular set of cash flows, it might be negative. And then I can look at other details too, like how is my cost of equity affected, and what's my leverage beta, and so forth. These are all things that are discussed in the article, and it gives managers a chance to kind of experiment with these values and see how their specific projects might be affected, as well as enter in their own cash flow information. So that's the idea behind this. And what it does is it moves managers away from just reading an article and thinking, yeah, I need to think kind of broadly about how my cost of capital might be affected by a variety of things, to some specifics around what does it mean practically in terms of what different reference rates might I be using, what kind of borrowing spread do I have, or what's my forecasting time horizon, and look at how that's affecting my ability to, or the way I'm accepting or rejecting projects. One of the other things that's kind of neat about this tool is for subscribers to the magazine, to the Harvard Business Review, there's the ability to save and load different scenarios. So here we can see different cash flows, and I could enter in real cash flows for a project that I'm considering and save that and use it for purposes of explaining things to my colleague. again, this is sort of an example of how a tool like this, a predictive analytics tool, can be used to influence organizations. All right, from there, what I want to do is move into showing how predictive analytics tools with support for leadership, again, can influence or can help with anticipating events in the future. And for this, I have a couple examples I want to show in these areas, or in this area. One of them is with this company, CBRE. And CBRE is a American commercial real estate company. It ranks currently 387 in the Fortune 500. And the problem that consultants within CBRE face, or their clients face, I guess, is that you need to plan for your demand and supply in real estate. And the premise that CBRE shares with their clients is that where and how a company is located in owned and leased properties, and who works there and how often and how the space is configured can be a powerful tool for driving change, innovation, and growth. So there's this plan of how do you go about matching your supply of buildings to the demand that you have for office workers, for example, or other kinds of workers in your facility. And there are really three parts to this. There's the owned or leased property. So you can imagine, for example, a large company that might own some of their own buildings. They might be leasing other buildings. They might also be have options on leases for other types of buildings. And so they have this portfolio of things that they're looking at to accommodate their workers over the next few years. And then there's the workers themselves. And the issue there is who works there and how often, who's going to be showing up to the buildings, who's going to be actually located in the facility, and how often are they there, and how do they work. And then lastly, it's a big one, is how is the space configured? So, how many people can sit per square feet? Are there things like hoteling, or are people telecommuting and things like that that can influence too? And from a dynamics perspective, there's sort of interesting behavior that occurs. So, here, for example, we have a hypothetical curve for employee demand over time. And you can see is that, it's changing, it's growing, it can grow rapidly, and then, it might go down for some reason if people are moved to another division or something shrinking, or it can grow back up. And in general, employee demand, the demand for space by employees can be fairly volatile. Whereas office space is often constrained, that first off, it doesn't behave the same way. It tends to be chunky, right? You either have a building or you don't, or maybe you can get additional options on floors, but it tends not to be as smooth. And secondly, the delays are longer in it. So when you kind of overlay these things together, you can see part of the problem that companies face with respect to real estate planning. And what CBRE wanted to do is to augment their consulting practices, provide a tool for analyzing this. And unfortunately, one of the challenges with predictive analytics tools that help with organizational leadership and are strategic is that organizations generally don't want to share them. And I was given permission kindly by a couple of organizations today to do so, to share some of these things. And CBRE was one of them. IBM is another one for later. But CBRE has granted me permission not to actually run the simulation today, but just to show you some screenshots from the interface. I'm going to just show you 3 of them to give you a sense for how this works. But here what we're looking at is the supply side. And what we see here is the supply of office space for real office space. And I guess this is in, it looks like Boston. So we see Copley Square here in Braintree and some other spaces that are available. And there's an amount of square foot that's available, as well as the current seats, the number of seats that can be in here. And what can happen is that brokers and other people that are responsible kind of for canvassing the area for available space would be entering in the supply information, and then make it available for running various scenarios. So this is the supply side of the problem. And then there's this idea of unit gearing, and this is really around the concept that I talked about kind of in the middle, which is that depending on how your workers work, it can influence the number of seats that there are demanded. So if you have people who work from home, you have people that are working in a more flexible team environment where they're moving around more, or maybe working collaboratively on big tables together, something like that. All those things can influence the headcount per seat or the amount of space that's needed per employees. And then this all comes together to produce this scenario planning tool. And the idea with it is that we can plot on the bar graphs here the supply of real estate that is available over the next several quarters against various demand cases, right? So you're trying to say something about the future and anticipate this change, and the demand cases can vary. Sometimes you're like, well, I don't know exactly how many employees I want to have in the future. It depends on how well certain products sell in certain divisions and things like that can influence it. And what I want to do is compare those various demand case scenarios against various supply cases and run them together and be able to share them. And one of the nice things about providing this online, well, there's many nice things about providing it online. One is that the models are centrally located and secure versus, say, if you're sending these around in by email with a spreadsheet or something similar to that. But another one is that it's easy to share these with clients. So after these things are built up, there's the ability for clients to log in to experiment independent of presentations that are being made with consultants that are explaining sort of what the plans are for real estate going forward. So that's another example. The fourth example I'd like to share today is around, let's see here, oh, there we go, around smarter cities. So this is a project that IBM worked on and we helped with around allowing Portland, in particular Portland's leaders, to see how city systems work together. And the purpose of this was to identify opportunities for Portland to become a smarter city and to develop metrics for something that was called the Portland Plan. And the Portland Plan was this roadmap for the city's success over the next 25 years. So the goal with this was to work with the city of Portland. The target audience for it were city planning officials and urban planners, and even actually the mayor of Portland, Mayor Sam Adams, was involved in this project too. So let me show you how that simulation works. I'm going to go ahead and log into it. And what's interesting about this sim is that this is both an analytical tool and a way of exploring how parts of the city are interconnected. So when you first log into it, what you see is this overview page that include a number of subsystems that exist in the city. And so, for example, I can see utilities, emissions, transportation, government, wellness, education here. And by double-clicking on a node, I can see information about what's inside that subsystem. So, for example, under utilities, I see electricity consumption, peak electricity, and water demand. And I can also click on links between two subsystems. So, for example, if I click on the link between wellness and transportation here, I can see that it includes active trips. And from there, I can click through and see how transportation and wellness are connected through active trips. So here I can see this connection here of trips active that are influencing the healthy population. And there's a couple of ways that they're being influenced here. I can see that it's being influenced by the effect of percent trips on obesity. And I can actually also flip that around and look at the reverse of it, say what happens in terms of healthy population affecting trips. So here I can see that as the healthy population increases, the number of active trips by bicycle or by walking can increase over time. So there we can see a little bit of some of the feedback that exists in the system. And what's interesting about this, if you think about this, is that that means there's sort of these long connections that exist among various subsystems within the city. So for example, one of the things that you can sort of discover by using a tool like this is that something like obesity can be connected to active trips and perhaps surprisingly have a carbon impact. So if I link to total CO2 tons citywide, let me try that here. So there's total CO2 tons citywide. From here what I can see is that healthy population is connected to total CO2 tons citywide, and it links through a number of factors. So this is sort of giving an indication of how various parts of the city are interconnected in potentially some surprising ways. And in addition, one of the things that city officials and urban planners recognize is that it's easier for the city to provide services in dense urban areas. And Portland refers to this as something that's called 20-minute neighborhoods. And the reason it's called 20-minute neighborhoods is because all major services and amenities are accessible within 20 minutes of in these denser neighborhoods. And another thing that comes up is that cities are really concerned about equity. So, the resident location is highly correlated with various populations, such as ethnicity or age or income. And so it turns out that city maps are a really good way to review and improve on equity, even if you're not explicitly modeling various residence populations. And so what Portland and the Smarter Cities Project used these city maps to explore how cities might change over time in various areas. So, for example, I can use this to see how city density can grow over the next 20 years or so. You can see here that the city center is getting even denser, but the eastern areas of the city, which are the older areas of the city, are getting denser as well. And I can look at other things here, like, for example, where are jobs located? Well, perhaps not surprisingly, jobs tend to be in the city center and not in sort of the outskirts of the areas outside of it. Where are things in terms of single-family dwellings? Well, they aren't generally in the city center, and it's not changing that much over time as well. That some areas are growing more in terms of the outlying suburbs for that. Then there's the policies page here, and the policies page can be used to make to set up assumptions and policies in the simulation. So, for example, what I might be interested in is smart meter coverage. So I can go in here into utilities, and I can scroll to look for smart meter coverage within the city and say I want to increase the number of residential smart meters, and I also want to increase the number of commercial smart meters that are used throughout the city. So we're not using the traditional meters, we're using smart meters as we progress to 2035. And I'm going to go ahead and simulate that. And the consequences, what we see are the major influences of smart meter coverage on the city. And here we can see that it's having an impact on peak energy demand. It's slightly lowering it. It's also slightly lowering CO2 tons citywide, and it's having a small impact also on reducing electricity consumption. So what's nice about this is for people that aren't the model builders, obviously this is a big, complex model, and it's hard to know where all the interconnections are. It can take a long time to kind of dig through all of those and understand, I've made some changes in the model, what impact did it have? Just to look through the various reports on the dashboard can be challenging, and this ordered consequence report can be really helpful for people who are newcomers or unfamiliar with the underlying model. And this also becomes really valuable when you want to look at policies, so in scenarios in particular. So scenarios in this simulation are coherent sets of policies that are implemented to look at what the future of the city might look like. So earlier I was talking about 20-minute neighborhoods, and you can see here that under 20-minute neighborhoods there's a bunch of things that might change over time. And I can load this in as a scenario and also then look back at these consequences pages and look at all the things that sort of this set of coherent policies that come together to create a scenario can show the broad consequences citywide. And what I can see is that based on this particular 20-minute neighborhood scenario, that we're increasing the number of walking trips, reducing vehicle trips, and so forth. And if I looked at details, for example, in the dashboard, by clicking on transportation here, and then let's see here, I want to compare this from the base run to the current run here. There we go. So what I can see is that my 20-minute neighborhood policy has this impact of increasing the number of person trips by bicycle, increasing the number of person trips by walking, increasing the number of person trips by transit, and reducing the person trips by vehicle. So just looking at over a 20 or up to 2035 time horizon. this is broadly kind of what the Smarter Cities tool is about. It's a tool for understanding these interconnections and these different subsystems within the city and experimenting with how policies might influence the future. So what I'd like to do is just kind of draw some broad conclusions about what we saw from these 4 simulations that I've been demonstrating today, and how they work with respect to helping people with engage in audiences and anticipate the future. So one of the things that we've seen is that there's kind of this tendency with respect to the engagement level, hopefully. That if you have a simulation that has a large number of users, that what that tends to mean is that people engage with the tool, with the analytics tool, for shorter periods of time. So the Latino Vote Map is something that can be played in a couple of minutes. The cost of capital tool has relatively a little bit more in it, and probably a smaller audience. And the consequence is that you might engage with it for 10 minutes to an hour or something like that. Whereas these bigger policy simulations and strategy simulations that we were showing with CBRE and Smarter Cities can often, people spend tens or even hundreds of hours working through and looking at combinations of effects. Another piece to it is that larger audiences tend to require fewer and simpler decisions. So in CBRE and in the IBM Smarter Cities case, we saw lots of decisions and lots of policies that could be set, this ability to create different scenarios on both the supply and demand side for CBRE. And again, there's maybe dozens or even hundreds of decisions that can be combined together to create different kinds of policies and scenarios. Whereas when we're doing things that are for a much wider audience, either in hundreds of thousands of people in the case of the cost of capital tool, or millions of people in the Latino Vote Map, the decisions tend to be fewer and simpler because you're just reaching a wider audience. And then lastly, we want to focus on that the shorter time horizons benefit from real-time data. So what we see is that, for example, the cost of capital tool, as I mentioned, loads in real-time data from the St. Louis Federal Reserve, because what matters in this is what's happening right now with respect to cost of capital, right? We don't want to use old data for that. And similarly with the Latino Vote Map, we wanted this ability to get data that's at least updated, weekly, and then kind of sitting in between that is a real estate simulator where we're pulling in data from a variety of sources, sometimes entered manually by individuals who understand what's happening with the local real estate market, and also pulling in data from other databases to create that. But for something that's a long-term planning tool like Smarter Cities, that live data connectivity is a bit less important. Just to wrap up, what I'd like to do is talk a little bit about the development process and what's involved in creating tools of this type that are available for online and that can be shared among either hundreds of people in the case of like Smarter Cities, or up to millions of people in the case of Latino Vote Map. And I'd like to talk about it from the perspective of different approaches that you can take to building analytic tools like this. And broadly, there's 2 kinds of approaches that you can take. You can do sort of simpler DIY tools that have simpler interfaces that aren't maybe highly polished and things like that. Or you can do high production value style simulations. And of course, for today, what we focused on is showing simulations that have high production value polish and things like that. So there's differences in terms of teams and style for doing each of these types of simulations, but both of them can be done. When you're working with a DIY team, if you're doing it, it's possible to build simple examples on your own, just as a modeler, for example, and learning a little bit about designing the interface, designing interfaces online, or potentially working with a user interface developer to create it. But when you're doing high production things, it really requires a team. And so there, it's a combination of consultants, of modelers, of user interface designers, people who are user interface developers who are working on the front end. There's system admin that needs to go in to make sure that the system stays up and running, is solid for the length of time that the tool is going to be available. There's a team of quality assurance people that are testing the tool on different browsers and things like that, and a project manager. And what I'd like to do is sort of characterize this as a different style of working, that the DIY approach is like a traditional modeling project with some front-end development. That's sufficient for doing these DIY-style projects. But for high production value simulations, it's really closer to a software development project. It's like producing a unique piece of software, and thus all the people that are involved, that team, is more like what is a software development team. And just broadly, if you're going down this path of doing a high production value simulation, again, there's a process that looks to me a lot more like what a software development process looks like, where you do this assessment. There's a design process that goes in where there's mock-ups and a functional specification that are put together. There's development, testing, and release. And what you can see out of this is that, in a traditional DIY project, most of the work might be done on the model and little work done on the user interface. Whereas when you're going to something like this, or something like the examples that I've shown today, that the hours spent developing a project tend to be heavier actually on the development of the interface and the design and things like that, because there's so much more that needs to go into testing and things. So that concludes sort of this overview of various tools. And if you have any questions for me, we can ask them now, I believe. Bob's going to field some of those, I believe, for the rest of our call today. But also feel free to email me at mbean@forio.com. I can't, unfortunately, I don't have the ability to share the logins and other information for sort of the strategy tools for IBM and CBRE, but these other tools are public, and you can take a look at them if you go to latinovotemap.org or forio.com/simulate/HBR cost of capital. You can find the cost of capital tool. And there's also this ability to try the DIY style things if you go to forio.com/simulate. Thanks.
Thank you, Michael. This is Karim. The immediate question is, you sort of addressed it when you said that you spend more time on the user interface than on the model, but, people are kind of curious about how much more. Like, is it 10 times more spending on developing a high production interface versus developing the model? And you might want to break that down into actually developing it in the design work. Do you spend a lot more time designing the interface versus figuring out what to do with the model?
Yeah, sure. There's lots of approaches to doing these kinds of designs, but this approach here that I outlined at the end of the presentation, it has worked well in the sense of it's important when you're doing these kinds of projects. They're pretty new projects for organizations still, right? Like we're still at the beginning of adoption, I think, for organizations to be looking at this. And one of the important pieces is there needs to be documents where people who are responsible for the projects can they can share them with their colleagues and show, hey, this is what we're going to be doing. And so one solution to that is to put the design up front. There's other approaches that are more agile-based where you do the design iteratively throughout the entire project. But we found that the better approach for us is to do the design at the beginning, because what you have out of that is, as I was mentioning, a series of wireframes and mock-ups in this functional specification. And not only is it useful in terms of defining precisely what is going to be built in the project, but it provides these sets of communication documents that can be shared, internally. And to answer the question about the portion of time, obviously it varies a lot by the type of project. But what we've seen is, something like 25% to 50% of the project is on the modeling side of things, and the remaining amount, 50% to 75%, is the combination of design, development, testing, and release here. So it's all the things that kind of surround it. So you can think of it somewhere between half and 3/4 of the effort goes into getting all of this running and sort of polished in these what we're calling high production value simulations.
Great, thank you, Michael. Following question is, did you build these projects using XMILE? If not, would you build projects like this using XMILE?
Yeah, great question. We would definitely use XMILE in future projects. We can't use it right now because we don't have the ability to convert them yet. But I know there's a lot of work going on at the System Dynamics Conference this summer to get sort of approval on the XMILE standard. And with there's obviously this sort of infrastructure effect with the XMILE project, but but it would benefit these kinds of projects enormously if if there were wide adoption of the XMILE format, and we would benefit from that, and it's definitely a great direction for us to go. So I think even right now we have, I think, and Stella that support the XMILE format, and that's certainly even enough to get started in order to be able to pull these models in, because the modeling work, you definitely don't want to do it online in general, right? You want to be able to use desktop tools for iterating through the design of a model and the way a modeler traditionally works. And it's only at the point when you're publishing the model and making it available online do you want to get that model in there. And XMILE is a great format for doing it. Historically, what we had to do is take broadly two approaches to get models into a server. Right? One of them was collaborate with other partners, vendor partners. And actually, within the system dynamics community, it's been great, because both isee Systems and Ventana have been really good partners in being able to connect in and be able to collaborate on being able to host things. So that's worked nicely. But then in addition, there's this ability of translating models, and translating a model where you're just looking at the raw model code that's kind of proprietary, not proprietary, but if it's a text-based tool, then you're sort of figuring out how you can re-implement that text-based information into another modeling language can be really challenging. And the SMILE concept resolves that. So that's going to be a huge benefit for us in the future.
Thank you, Michael. Someone asked about your high production projects. Do you typically host them, or do you deliver them to the client to host?
Great question. It varies, actually. And what it depends on is concern about client security, and also kind of trading that off with load on, say, an IT department. So, for example, that CBRE project that I showed is completely hosted internally. And the reason for that is that there's a lot of issues around client confidentiality, and they're working with banks and other organizations that have very strict rules regarding how data is shared and things like that. Even though the application isn't about customer data, it sort of applies to any kind of IT infrastructure that exists within a bank. So the hosting for that tool is actually done by CBRE directly, and they have their own IT staff for hosting it. But for other things like the Harvard Business Review tool, they've chosen to have Forio host it for them. And so we manage all the hosting, but there's a cluster of servers that are dedicated to them, but we're just managing the hosting. And I guess there's this third option, too, which is more of a traditional SaaS-based solution where you can just log in and kind of more arm's length have a simulation hosted as part of it, using our platform.
Fabulous, Michael. For smarter cities, how were the relationships determined and validated? How was the data used, say, compared to subject matter experts' opinions?
Yeah, so there are a number of steps in that, and it's pretty much like what you probably have seen in other system dynamics projects, in that there's a huge amount of upfront work that went into it. So the approach was initially to interview about 30 or so subject matter experts across the globe within IBM. That IBM has had this big initiative around smarter cities, and there's a lot of internal expertise within IBM among their hundreds of thousands of consultants on how smarter cities operate. So that was the starting point, but that produced kind of a generic model that that hopefully could be applied to any city. From there, we went into the specifics of working with Portland, and I'm trying to remember how many subject matter experts there were. There's something like 75 or 100 experts within the city of Portland that got involved in working through how that, what the interconnections were and the tuning of the model and things. And there's lots of work that went into documenting the individual connections and things like that. So, if you look at that project, probably 3/4 of it was spent on all that stuff, on gathering information about the relationships and validating those relationships and the interconnections and things. And then and then after we got all that in place, the user interface was built on top of that. And one of the things that we're looking for, you can kind of see that in the Smarter Cities project as well, is that there is this analytics piece to it of that, analyzing what might happen in the future. But a big part to it too, as I was mentioning, is just understanding what the interconnections are, like understanding where there might be subtle and surprising influences in there. So that's what, in addition to doing an analytics analysis, doing the analytics side of it, we were interested in exposing those relationships. And it turned out that using diagrams was kind of a challenging way to do it. Like we're doing, say, a causal diagram with a group of, say, 75 people. Usually what you'll have among those 75 people is there'll be one person who's an expert in transportation, for example, and somebody else who's an expert in wellness. And they're they're broadly interested in the whole project, of course, but what they're really interested in is learning more about, is this thing built correctly for the area that I'm an expert in? And if you're sharing a giant causal diagram, that can be really difficult. It's kind of simultaneously, it can be too complicated because there's so many interconnections, and also too simple because the connections that matter to that person are obscured, right? So that tool where you can drill down into subsystems and type in individual variables and look at connections was very valuable for them.
Following up on that model, Michael, was any real data fed into that? Any live real data used?
There was lots of real data used in that project. So there's all kinds of, both in terms of the information about, the budget, the population, various types of populations that exist in the city, by district, as we were outlining. There wasn't live data. So, in these other projects, to a greater or lesser extent, there's live data feeds, right? There's this ability to kind of update it weekly or monthly. But for a planning model where you're looking out 25 years into the future, that's less important, right? Because the plan is to use the model for a year or two, and then we're going to try to make some decisions about what's going to happen over the long term. And you could go back and look at it, say, a couple years later or 5 years later and revalidate it, but it's not really necessary to have live data feeds to do that. That would be overkill.
Terrific. Thank you, Michael. Someone's asking about predictive analysis. They say it's rather trendy, but other techniques than system dynamics are generally used, for example, regression. How would you describe the advantages of system dynamics?
Well, I mean, system dynamics within, so you're right, there's lots of techniques out there, right? So there's regression is used, there's optimization, there's other kinds of simulation techniques like discrete event or agent-based modeling. There's machine learning is very trendy right now, right? So there's a whole bunch of things, and it's exciting actually to see all this. And actually, I think these techniques can be combined together. It's really interesting to look at ways of combining, for example, optimization techniques with simulation, for example. There's a lot of that can be done with that. But I think that the advantages that system dynamics has had historically relative to those other techniques still apply within predictive analytics. And specifically, system dynamics is great at looking at large kind of organizational or problems that occur over multiple weeks, months, or years. And there's also an advantage from the server side in that the way that system dynamics models are constructed, they tend to run really fast on a server relative to, say, an optimization tool. Sometimes optimizations can take, a supercomputer to answer the question, even that's running for 15 hours or something. Whereas system dynamics models tend to run fairly quickly. You can run them in, often milliseconds, but even for big models, it's going to be in seconds or maybe minutes or something like that. And what that does is it allows for experimenting with multiple scenarios. So it really lends itself well to doing online experimentation because, if you're doing something like an optimization, unless it's a small one, if you're running it, you want, for big ones, it's going to take, like I said, if it's taking 15 hours, it's not really a great online experience. But if you have something that can run in seconds, then it can be very, very useful. And system dynamics is a good tool for that.
Great, thank you, Michael. I'm going to take the last question here, which is a follow-up to something you mentioned earlier about getting models to run in your web system, in Forio. They're asking how is the connection made between system dynamics models that people have built on desktop platforms and into Forio. Do they have to recreate those models within Forio?
No, they don't. So the way that works is we have partnerships arrangements with both isee systems and Vensim, and we can host those models on our platform. So you just take the models and you can upload them. And there's different approaches for doing that because there's unique aspects to each of those tools for getting them in. But once you build them in the traditional desktop modeling tool, and then you just upload them essentially. And that's been a challenge for us. We've spent, I don't know, thousands of man hours probably putting those things together. But I'm hoping that in the future, because of the XMILE format, that's going to be a lot easier. So, but you don't have to re-implement your model in a Forio language, for example, to get it to run.
So thank you so much, Michael. That was a fantastic presentation, and thank you all in the audience for attending. We've seen some really great examples of work done in system dynamics in a variety of different areas, and the next 3 webinars that are coming up are going to focus much more strongly on the XMILE standard and what it means, or what the basics of what it is, what it can do, and we're hoping you will join us. We're very interested in getting more feedback on the way the standard is going and get more engagement in places where people might be able to use the standard in doing new work. So the next webinar is scheduled for April 29th, and it will be an introduction to the language, and then we're going to be able to look at some of its simulation capabilities and go a little more into detail. And finally, on June 24th, we have a panel discussion with people, many of whom you will have heard presenting here, and the system dynamics community to talk about the value of that. I hope you'll be able to join us for all of these leading up, as Michael mentioned, to the System Dynamics Conference in Delft this summer. Thank you so much. Have a good day.